Hello everyone, it's April 4th, Sunday. Alright, let's do it today. First take a look at any notification. I need to go back to this question. I actually forgot how to solve it. Find medium from data stream. If I ever encounter the question again, I think I'm gonna fail. Anyway, so yeah, let's go for it. Are they going to give us another hard question? Design circular queue. Okay, let's take a look. Design your implementation of the circular queue. The circular queue is a linear data structure in which the operations are performed based on FIFO principle, and the last position is connected back to the first position to make a circle. It is also called a ring buffer. I might have heard of it, right? So what's the operation? So you push in the front, so there's no front, no back. Oh, I definitely have. Now I remember ring buffer. So this like you push in the front, and I mean first in first out, right? First in and first out. How do we ring it? The last position is connected back to the first position. So the last position is back to the first position, which means if the queue is full, well, which means if we go to the last position and if we want to keep pushing, then we can still push new data, and that data will be in the front. Okay, okay. Yeah, I know how that looks like. So it's think about an array, and the data is just going around in the ring, going around. So we can keep always pushing the front, and then we can pop in the back, pop in the back. Okay, okay. I have a mental image of how this one looks like. A safe space. Yes, the space in front. And make sure that you use the space in front of the queue. A normal queue, once the queue becomes full, we cannot insert the next. Yes, even if there is space in front of the queue. Well, when you say in front, I mean, in my mind, front is where you push in, and the back is where you pop out. So I would say you just use the space in the back of the queue. But it's fine. I know what the question is talking about. Using a circular queue, we can use the space to store new values. Yes, that's true. So we're going to implement it. Initialize the object with the size of the queue to be k. Okay. Front gets the front item. If the turn rare, do we pop as well? Gets, it just say gets? No, we do not pop, we just read it. In queue, insert, return true if the operation is successful, false if it's not, I guess. DQ deletes an element from the circular queue, return true if the operation is successful, is empty, is full. Okay, so basically, I think this is maybe an easy question. Without the built-in queue. Yeah, I am not planning on using the built-in queue. Oh, wait, we have deck. Okay, so what's the data structure we're going to use? Just a list? All right, let's write it out. I have my trusted paper. Let's see, which paper do I use? I'll just use this one. Here's some paper. This is my scratch paper, which is actually just an envelope. That's why you guys can hear a suspicious noise. Alright, so we're going to use a regular list, right? A regular list. And so we need definitely 2 pointers, like one at the back, one at, okay, so let me define my back and my front. All right, so that's very important. So for this, right, my front is here, the right. Okay, let's say left and right. So we need one, but the left and right will switch. So I shouldn't say, no, I should say front and back. This is my front. This is my back, because I'm always adding things to the front. I'm popping things at the back. So we're gonna have a B and when I have an f, initially b and f are pointed together, and actually, initially the both b and f should be pointing to emptiness. Then we can check. I mean, front and back. Okay, this front and back is different from my front and back, guys. Front, the last item. Okay, I want to see what does front and back mean. Okay, so in Q, 1, 2, 3. In Q4 is false because it's full. Rare is 3. So for them, rare is here. Okay, so maybe I should use their notation, which means this is front and this is rare. All right, that's fine. That's fine. No hard feelings. So 1, 2, 3. The rare is 3. Is full is true. We can DQ. We'll be getting 1 out, right? DQ will be getting 1 out. In Q4, the rare is 4. Yes. Okay. All right. So I'm gonna change our. I'm gonna front and rare. So it's gonna be R. Will be rare. No, rare is the back is rare. So this is rare. This is the front, right? So as we go, the rare will move every time in Q. The rare moves, right? How about the front? Every time in Q. Now let's do. Let's pointing them to the first one. So in Q, we put it in, and then rare goes forward, right? In Q again, rare goes forward. If we DQ, then front goes to the right, like front goes forward, right? And then that is all fine and dandy. And then we is full is just the difference between f and the pointers. If that equals the size, and that's that. Is empty is the same thing, so that's fine. That's actually not fine if they're pointing at the same thing. Is full and is empty. Is full. Okay, so how about DQ will be rare minus front, right? If rare minus front plus 1, that is the actual thing. So what you mean is the rare minus front plus 1 would be 0, right? And then we're in Q, we move rare, and if we DQ initially, it shall return false because nothing is in there. So, how do we track the number? I guess we'll just use another variable to track, because it is pretty difficult to say like the 2 pointers, the difference between the 2 pointers. Because the 2 pointers, they can point to the same thing and it could still be empty from the start. So yeah, we keep track. We use a internal value to keep track of the length, the current length we have, which will be much easier for us to answer is full and is empty. And also to consider in Q, if it's full, we cannot do in Q. Okay, so that's done. And as we are going forward and we are full, and if we pop, how do we wrap around? Well, we can wrap around using mod, right? Both front and back we can use mod. Yeah, both front and back we can use mod. So if R going to the end, and then we want to enqueue, and we found it's possible, then become r plus 1 mod the length, right? Mod the length, which will become 0 again. Oh, if that's the case, I think this might be an easy question. Well, I should not say this anymore, because I think in the past few days we have encountered many quote-unquote easy questions, and then it's only after I fail to pass the first time then I realize, nope, it's not easy, and actually a few of them turn out to be difficult. So I am not going to call this an easy. I do not think this is easy. Always treat it as if it's hard. All right, so we initialize. So we need the size. Internal, we need the size. And we need a front. And we need a rear. So get these straight. Oh, and we need self dot q equals value is 0 to 1000. So we're gonna use -1. Times k. Okay. So enqueue. So we do this first. No. Oh yes. These shall be easy. This is just like if self.size and then return self.q front if self.size else -1, right? It says if it's nothing front if q is empty, return -1. Yes, so that's that. And the rear will be the same. Instead of f, we're going to be r, right? Is empty, return self.size. Is it empty? Equals 0. That means true, right? Is full, return self.size. We can't just say return not self.isEmpty. All right? No, I don't like that. Because it's easy to write, so we don't have to do this smart-ass thing. It just says not equal to 0. If full is true, right? So we've done these. So now it's enqueue. So enqueue, we're going to say if self dot is full, we're going to return false, right? Full we cannot do. Otherwise, we say we're gonna say self.q, right? And then we say self.r plus 1, and we have to mod it with self.size equals value and return true. And we're going to do it almost the same for dq, and then we'll just say if equals empty. What are you doing? Empty, then we say false. Otherwise, we are just going to say self dot, oh, hold on. That's actually not right. We have to increment this. And then we say self.r. Here is same, so that front equals front plus 1, turn true. And I guess that's pretty much it. Oh, no. Don't forget to increment your size. And don't forget to decrement your size. Size minus equals 1. Okay, this probably is right. Take a look. Let's see if this one passes. Ooh, integer division or modular by 0. Huh? Oh, not size. Dang it. Capacity. Self.cap is k. That's right. That's not size. It's cap. When you do this, it's cap. Not size, it's capacity. All right, do it again. Oh, what do we have? We have an error here. And what the heck? Why you do this? Self dot. Ooh, that's not correct. There's a lot of things not correct. What the heck? True. False. What's the next? Hold on. In Q, why do I return false? Oh, wait. In Q, right? We do this, and then we in Q1, I say it's good, and I say in Q again, and I give false. Why? I call self dot is full. Oh my god. It's not 0. Cap. There's so many wrong here. Naturally, I need to copy and paste because I think I changed something here on the, yeah. It's dot cap. No, and also not equal to is full is equal. That's fine. What the heck? Terrible. All right. True, false 3, true 4. Okay. Do we dare? Let's dare. Pending. Oh, we got wrong answer. Take a look first. Did we pass any? Oh, we want to pass a little bit. Ah, man. Okay, so I didn't read it for now. Let's just think about why would it be wrong? Like, what did we do wrong? We keep in queue. Every time in queue, we check if it's full, right? If it's full, then we return false. If it's not full, we move R forward, right? We move R forward +1. We do the mod thing, so R will be, yeah. And then we put the value inside. And then self.size +1, yeah. DQ, we do the reverse. We don't have to delete anything. We simply moving the front forward, yeah. And then we mod the cap and self.size. Okay. Like, what is the problem? Oh, I think I might see the problem now. If I inQ3 and then DQ3, right? Inq. After I inQ. Oh no, this is wrong, right? I shall change the value first and then move on to the next one. No. Alright, so what we want is for self.r always pointing to the last one. Therefore, we always move forward and then go, which means our starting position shouldn't be -1. Think about it. We always increment and then change the value. So I think we should be -1, both front and back. They should point to -1, which is not a real position. And then every time we increment first and then read. And for DQ, I just move it forward, right? Every time move it forward. Okay, let's try if we do -1, will this work? Naturally, I want to clean. And then we run the test case first. I'm actually going to change a little bit. So this one still passed, but I want to change a little bit. So we have, let's just run it. Let's just run it. Too lazy. We got it wrong again. Maybe it's time for us to run some test cases, some better test cases. So what type of test case are you thinking about? Let's see, enqueue. So we enqueue 3. We call rare, we call this 4, and then we dequeue, right? We dequeue 1, and then enqueue again, and then we call rare is 4, and we can call front, right? It's called front. That should be 1, that should be 2, and then let's dequeue more times. Right, this is 3, so we can dequeue once, dequeue twice, dequeue 3 times. So dequeue, dequeue, and dequeue. So dequeue once, dequeue 3, dequeue once, dequeue twice. So we have 3, right? Dequeue once, 2 gets out, so 3, dequeue that, right? And dequeue 3 times. If I dequeue 3 times, where is my F? I think this is the problem. This is the problem. Because if I dequeue 3 times, I think the F is moving too fast. Alright, I'm going to draw it out. So we have enqueue 1, 2, 3, right? And then F is pointing to 1, R is pointing to 3. And then they're both starting. Oh, yeah, that's wrong. We're both starting from the -1. So enqueue. If I enqueue, and then so move R, and then do this. What should I think it's the F. The F is wrong. F should point to the front. So let's say F is already pointed to 0. Like this is going to be wrong, I think. Yeah, see, this one's wrong. I pointed to the wrong thing, the one we call. So it's the F. F is the problem. So our way of enqueue R is going to be outside because every time we want to increment R and then do this, right? We increment and then do it. And every time we dequeue, we just move the F forward. So let's just say F stays at 0 and R stays at -1. So if we enqueue, move here, enqueue, R is going to be 3, F is going to be 1, and then we check front, that's working, and is full, is working, and then we dequeue, enqueue. So we dequeue, we move F forward, right? F now pointing to 2, and then we dequeue, and then when enqueue, then R comes to the front, and we enqueue a 4, so we put a 4 here, and then we call rare, we get 4, and we call front, we get 2. Yes, yes. And then we call dequeue, dequeue, dequeue. So we call dequeue once, F move here, dequeue twice, F move here, and dequeue 3 times. F actually move to a position where there's nothing there. I think this is going to be correct. So F has to be ahead of R. And if we run code this time, it shall succeed. And we're going to put a new thing. So now, yeah, now it shall work. Try it again. Pending, judging, now we're good. So that's the trick. The F has to be 0. Right? F has to be 0. F is 1 ahead of R. That is the trick. Everything else, I think, I just copy and paste just in case I change something here that I forgot to change back here. See, even if it's an easy question, it's still troubling you, right? It still make you. I think we failed like 2 times. So never underestimate any questions. This is a fairly straightforward question, right? Fairly straightforward question with only one trick. How to design the pointer that points to the front and rear of the circular cube. The answer is that when the cube is empty, the front pointer is always one position ahead of the back, the rear pointer. Yeah, that's just the trick. And of course, in our implementation, the rear pointer has to start from -1. The wraparound is a simple mod. This is on right? Everything's on, and we run 68 milliseconds and a 72% ranking. Okay, so now it's time to check what other people have done with it. They might have a slightly better solution. Okay, so I think we satisfy everything. That's fine. We can do that. We can do that. Like here. Boom, list. Now everybody's happy. All right. I got this. There might be no solution. Checking problems. This might be an easy one. No, it smells medium to me. It smells medium. Yeah, it is medium. We have 2. Probably slightly different. Solutions locked. It's a good question. I like it. Submission. Yeah, I failed 2 times. All right, let's see the discussion. Using array, single list. Let's see, what do you do single list? Posted 2018. Max size, front rear. The both, oh, this is slightly different. They said both is -1. If rear, and they have to check. They have to do extra check. And we don't do extra check. I think our solution is better. DQ, yeah, they have to check front and rear. We don't really check. All right, I think that's about it. Oh, they do all 0. How? See, if you do the same, your front has to change here, right? If you do like me, which we have a stacked front and rear, they have a difference. Then you don't have to do extra checks here. And I think he is just like incrementing and decrementing. That's it, right? In Q. Why self dot n -1? No, he's always do y and -1. Anyway, so that's it. That's it for us. It's a pretty straightforward one. I don't see any reason to go I saw a double linked list. I don't even think it's necessary. This is it. We use just a list to implement it, and the trick is just to consider the front and rear, right? All right. We had a good one, successful one, and see you guys tomorrow. Adios.